Okay, we have here another integral. This one's from the MIT Integration Bee 2015, problem 13. We have the integral from 2 to e, natural log x all squared minus 1 over x, natural log x squared, dx. Okay, I did kind of struggle with this one for a while. The problem I had was more just being stubborn and not doing the obvious thing, because what I wanted to work here was the quotient rule. You can see it's pretty similar with the minus sign. We have something squared, but what about this x? Well, I tried it a couple different ways. One way is you can bring the x into the numerator, then you just have something squared in the denominator. The other way is you can multiply n by x, and then that becomes x squared, and then everything here is just like x ln x all squared. But it turns out the quotient rule is kind of a pain on this one, because it's still not, no matter what you do, it's not clean and it takes some doing. So I'm gonna kind of skip that, and what I want to do instead is really the obvious and probably the easier way, which is just split this up on the minus side. So we'll split this into two integrals. The first one, we're just gonna have natural log x squared over this stuff. And then for the second one, we'll just have this 1 in the numerator, so it's just gonna be 1 over the same denominator. But doing that, now we have cancellation over here on the left one. We'll just leave a 1 over x, and that's gonna be an easy integral. This one over here, this is a little more complicated, but it's not too bad, because if we do a u substitution on natural log x, the derivative of it, the derivative of natural log x is just 1 over x dx, which we have right here. So this is gonna work pretty nice. We'll do u equal to ln x, take a derivative, and we have du 1 over x dx. I'll go ahead and integrate this first one. Integral of 1 over x is gonna be just natural log absolute value of x, but everything's positive, so let's skip the absolute value. We'll just do natural log x evaluated from 2 to e. And then on the second one, we'll do our substitution. First, updating our bounds. Plug e in here. Natural log of e, that's just 1. Then plugging a 2 in, we'll just leave this as a natural log of 2. Then for everything else, again, we've got our du right here with the 1 over x. So this is going to turn into 1 over u squared. I'm going to write this as u minus 2 du, and now we can just do power rule on this. Before I do it, let's update this first one. So plugging in e, we're going to have natural log of e, which is just 1, minus plugging in 2, this is just going to become natural log of 2. Integrate here with power rule, this is going to be minus 1 over u, but minus times minus is plus, so we'll write this as plus 1 over u, and we just need to evaluate this from ln 2 to 1. I'll copy over this first part, 1 minus ln 2. Plugging in a 1, we're going to have plus 1 over 1, that's just going to be another 1. Here, minus 1 over ln 2. I can add these 1's up, and we can write this here as a 2. And this here, this is a fine solution, but I think what I'm going to do is try to get a common denominator and simplify it a little more, just because I like to match the solution that MIT has, and what MIT has for this looks quite a bit different than what we have here. So now, just to get a common denominator on this, I'm going to multiply by ln 2 over ln 2 on everything, except for this last one. So when I do it here, we're going to have 2 ln 2 over ln 2 for this first piece. And then here for the second one, this is going to become minus ln 2 squared over ln 2, and the last one's just going to be minus 1 over ln 2. So then we have our common denominator. Let's put this all over ln 2. But what I want to do is, I'm trying to set this up to factor it. Let's factor a minus out front. So when I do this, I'll reorder it. Now this ln 2 squared, this is going to become positive ln 2 squared. Here, this is going to be a minus here. And then reversing the sign on the minus 1, this is going to become a plus 1. But now we can just factor this numerator here. If you look at this as y squared minus 2y plus 1, let's say this is actually a perfect square. And you can write this as y minus 1 squared, where of course the y is just natural log of 2. So we'll use this and rewrite again. So this is going to be minus sign out front. Factoring the numerator, this is going to become ln 2 minus 1 all squared over ln 2. And that's it. Okay, there you have it. Good problem from MIT 2015. Thanks everyone for watching. Have a good day.